Welcome back to the deep dive. We are taking that stack of articles and research you sent over and, well, turning it into a precise, targeted guide for you.
Today, we're really focusing on the most fundamental part of driving, which is just control. Our deep dive is all about steering mastery.
It really is the difference between a minor adjustment and, a major incident.
Exactly. We're extracting the absolute essential nuggets on technique, emergency response, and vehicle maintenance, all customized for you, the learner, who wants to get up to speed quickly and thoroughly.
That's the mission today. Confidence. We want to move beyond just rote driving habits and dive into the physics and the mechanics that actually govern your vehicle.
And we're pulling this from some pretty comprehensive sources, defensive driving guides, technical manuals. The goal is for you to feel fully informed.
Right, about both the input you're putting into the wheel and the feedback the car is giving you.
What's really fascinating here is that even very experienced drivers, they often hold on to some really outdated advice. We're going to bust a couple of old myths.
Yeah.
Yeah, and replace them with what are really life-saving modern techniques. We're aiming for those aha moments that just fundamentally change how you interact with your car.
We've broken this down into three core areas. First, foundational techniques, specifically that big shift in hand position.
Then the scary part.
Right, the panic zone. Understanding and correcting a slide, using the physics of your car, and finally we'll dive into the crucial symptoms that tell you your steering system is failing and needs attention.
So let's start with that primary connection to the car.
Let's do it. Your hands on the wheel. For generations, we were all taught to imagine a clock face and put your hands at 10 and 2. But our sources are incredibly firm on this. That standard is completely wrong now.
It is. The 10-2 position is actually a serious safety liability in any modern car with an airbag. The safety experts all stress this. You should absolutely not use the 10-2 position.
That's a stark warning. I think most of us get that airbags deploy fast, but what's the actual danger here? What's happening?
It's the sheer velocity. An airbag deploys at, 150 to 200 miles per hour? It's an explosion.
Wow.
Yeah. And if your hands and arms are sitting right on top of that steering wheel hub, they're perfectly positioned to get in the way.
So they just get thrown back.
Thrown back violently. The force can shatter your arms, or, your hands basically become projectiles aimed at your own face. Early studies on this were pretty clear. They saw a big spike in upper body injuries directly because of this hand placement.
I honestly never considered that. It takes a completely routine habit and suddenly makes you see it as a potential hazard. So what is the new standard, the modern recommendation?
The consensus is either 9 and 3 o'clock or 8 and 4 o'clock.
Okay, so a wider, lower grip.
Exactly. And this placement, it does three things for you. First, it keeps your arms wide and low, safely out of that airbag's deployment path.
Right.
Second, it puts your hands in a prime spot to use all those integrated controls on the wheel, cruise control, the radio. And finally, it just gives you optimal leverage for fine control.
Okay, speaking of technique, let's move from the grip to the actual act of turning. This is where you see a lot of drivers still crossing their arms over.
They do, and that's another one of those legacy habits. The guides we looked at really distinguish between two methods. There's the overarm technique, which is that hand-over-hand crossing motion.
Right.
That's only okay for really slow maneuvers like parking or backing up, and even then you should use it sparingly because you're still putting your arm near or over that airbag zone.
So anything faster than a parking lot speed, crossing your hands is a no-go. What's the technique we need when we're actually moving?
We rely on what's called the sliding technique. Some call it push-pull steering. The main thing is your hands never cross that center line. You push up with one hand while you pull down with the other.
And the key rule here, speed matters.
Immensely. As your speed increases, the finesse of your input has to increase too. The higher the speed, the finer, the smaller, and the slower your steering adjustments need to be. The sliding technique naturally encourages these smaller inputs, and that gives you much better control and stability when you're moving fast.
Yeah, it makes perfect sense. High speed demands low input, high precision steering. Okay, let's transition now, because even with perfect technique, sometimes things go wrong.
Precisely. We're moving from preventative technique into, reactive survival. When your tires lose their grip on the road, drivers often hit that panic zone, and their instinct is almost always the exact wrong thing to do.
Let's simplify the two main types of slides, understeer versus oversteer. We need to define them clearly before we can talk about how to fix them. Let's start with understeer.
Understeer is when the car doesn't turn as much as you want it to. You turn the wheel, but the front tires have lost their grip, so the car just keeps plowing forward in a straighter line than you intended. You might feel the steering wheel go unnervingly light.
And what causes the front tires to just give up like that?
It's usually momentum and weight. You've basically asked too much of those front tires for the speed you're going. Maybe you turned the wheel too aggressively or you accelerated too hard mid-corner in a front-wheel drive car. The front tires just stop biting the asphalt.
So, okay, the front end is gone. My first instinct would be to crank the wheel even harder into the turn, right? Try to force the tires to grab.
And that's exactly what you shouldn't do. Our sources say it's totally counterintuitive. You have to focus on weight transfer first.
Okay, what does that mean?
It means you immediately ease off the throttle. That simple action shifts the vehicle's weight forward, putting more downward pressure on the front tires. That pressure helps them regain their grip.
So you let off the gas before you adjust the wheel.
Yes. Only then do you gently and subtly turn the steering wheel in the direction of the slide. You're actually straightening out a tiny bit, which lets the tires recover. Cranking the wheel harder just makes the slide worse.
That weight transfer piece is vital. Okay, now for the opposite, and maybe the more dramatic slide, oversteer. The back end gets loose.
Right. Oversteer is when the car is turning too much. The rear tires lose their grip, and the back of the car starts to swing out toward the outside of the turn. This is what most people call fishtailing.
And this happens when the weight shifts away from the rear tires, right?
Absolutely. The classic causes are, accelerating too hard in a powerful rear-wheel drive car, or, and this is critical, suddenly lifting your foot off the throttle while you're in a turn.
Right. Lifting off the gas can cause it.
Yes, it's a huge insight. When you abruptly lift off, the car's weight pitches forward violently.
Yeah.
That takes a lot of downward pressure off the rear tires, and they can just break traction unexpectedly.
So if I'm in a curve and I get scared and just lift my foot, I could actually cause the back end to slide out.
You absolutely could. It shows you how sensitive weight management is, but the correction is the same principle as understeer. Your focus has to be on corrective steering. You turn the steering wheel in the direction of the slide.
So if the back slides right, you steer right.
Steer right. If it slides left, you steer left. And your response has to be instant. We're talking milliseconds.
And this is where we get into that disastrous pendulum effect.
Yeah.
Overcorrecting. This is what turns a small, recoverable slide into a total loss of control. How does that start?
It happens when the driver makes the right initial correction but holds it for a split second too long. For example, the back slides right, so you correctly steer right. The car straightens out.
And you've saved it.
You think you have. But because the wheel is still turned to the right, the car's momentum immediately whips it into a violent slide to the left. Then the driver overcorrects left, and the slides just get bigger and bigger until the car spins out.
So the key isn't just turning into the slide. It's knowing the exact moment to undo that correction.
That's it, exactly. As the back of the car starts to recover and straighten out, you have to instantly and smoothly lessen the correction and straighten the wheel. You are guiding the car, not forcing it. The moment you feel the tires grip again, your hands must already be reversing that input.
That's a huge takeaway. Okay, that covers technique and emergency survival. But this all assumes the machine is working perfectly. Let's shift from the driver to the machine itself.
A great transition, because sometimes if you're struggling with steering, the fault isn't your technique, it's the health of your car.
Let's tackle a really common question first. Try steering. Wheel to it. Turning the wheel while the car is completely stationary. Is it actually bad for the car?
Yes. The technical manuals all confirm it's best to avoid it. A modern car can handle it, sure, but it puts a lot of extra strain on components like the tie rods and the power steering pump.
What's the consequence I'm going to see, though?
Tire wear. Definitely tire wear. Dry steering scrubs your tires against the pavement, creating a lot of friction and heat. It leads to premature, uneven wear, which means you're buying new tires sooner than you should.
Okay, fair enough. So always try to be moving, even just a tiny bit. Now let's look at the tech that helps us. Power steering. Most drivers have electric power steering now, EPS, but plenty still use the older hydraulic system, HPS. What's the difference that matters to you as a driver?
The difference is really about simplicity versus control. The older HPS, the hydraulic system, uses an engine-driven pump and fluid. It gives you a very consistent, sort of heavier feel at all speeds.
And the newer electric one.
The EPS uses an electric motor that's controlled by the car's computer.
So what's the big advantage of having a computer involved?
Customization and efficiency. The electric motor gets data on your speed and how much you're turning the wheel, so the computer can adjust the level of assistance.
Ah, so it can make it feel super light in a parking lot.
Right, for easy maneuvering, but then it can make it feel much firmer and heavier on the freeway for better stability. HPS just can't do that. Plus, since there's no pump constantly running off your engine, you get a little bump in fuel efficiency and you don't have to worry about power steering fluid leaks.
Okay, let's troubleshoot the feel of the steering. These symptoms are key indicators of a problem. Let's start with stiff steering when it's really hard to turn.
Stiffness almost always points to an issue with the power steering system. The first, cheapest thing to check in an HPS car is your power steering fluid. If it's low, that's your problem.
And if the fluid is fine,
Then you're likely looking at a failing power steering pump. A huge giveaway is a loud whining or squealing sound when you turn the wheel. That's the sound of an expensive repair that needs immediate attention.
and what about a simple cause?
Oh, right. Don't forget the simplest thing. Just having really underinflated tires will also make the steering feel sluggish and heavy. Always check your tire pressure first.
What about the opposite, which sounds much more dangerous? Loose steering or too much play in the wheel?
Loose steering is a major safety alert. It means there's a delay, a sort of slack, between you turning the wheel and the wheels actually moving.
And that points to worn parts.
Worn or damaged mechanical parts. We're talking about things like worn tie rods, bad ball joints, or a loose steering rack. These are the components that physically connect your steering wheel to the wheels. If you feel excessive play or a wobble, you need to get it inspected professionally right away. Do not delay on that.
And what if the wheel itself vibrates or shakes, especially at high speed?
That vibration is almost always related to the wheels. The number one cause, especially at highway speeds, is just unbalanced tires. It's a quick, cheap fix at any tire shop.
But what if it only happens when I'm braking?
If the vibration only happens when you're actively pressing the brake pedal, that's a dead giveaway that you have warped brake rotors.
Got it. Finally, noise. What does a groan or a whine when you're turning tell you?
That groaning or whining sound usually points right back to power steering fluid in an HPS system. The fluid is either low, old, or contaminated. If it's more of a high-pitched squeal, that's probably a loose or worn belt driving the pump. But if you hear a clunk, that's more serious.
A clunk.
Yeah, a clunking sound suggests metal hitting metal, and that often means a failing steering rack or tie rod ends. That's a big deal.
Now that we've covered the parts, let's talk about how they're aimed. I mean, steering control is useless if the wheels aren't pointed in the right direction. Let's nail down what alignment actually means.
It's fascinating because so much of your car's handling relies on these microscopic, unseen angles. Alignment is just the process of adjusting the angles of the wheels to match the manufacturer's exact specs. It is a massive factor in handling, safety, and even your fuel efficiency.
Let's break down the three main angles. There's camber and toe, but I want to focus on caster because that seems to be the one nobody talks about, but it's crucial for performance.
Caster is essential. So, briefly, camber is the tilt of the tire in or out if you're looking at it from the front. Toe is whether the tires point toward or away from each other, like your feet if you're looking from above.
But caster?
Caster is the angle of the steering axis when you view the car from the side. It's tilted either toward or away from you, the driver.
Why should the average driver care about their caster angle? What does it do?
Positive caster is what gives you directional stability. It creates this trailing effect, kind of like the front wheels on a shopping cart. It makes the car want to track straight.
Okay.
And crucially, caster is responsible for the self-centering action of the steering wheel. You know how when you finish a turn and let go, the wheel wants to return to center on its own?
Yeah.
That's caster doing its job. Without the correct caster angle, you'd have to physically fight the steering wheel to straighten out after every single curve.
That is the ultimate aha moment. It's a component we never see, but we rely on its function constantly. When should you absolutely get your alignment checked?
The sources say anytime you hit a big pothole hard, anytime you get new tires, after any suspension work, or obviously if you notice your car is consistently pulling to one side when the wheel is straight.
Okay, let's finish up with some quick hits on setup and accessories. How should your steering wheel be adjusted relative to your body?
The two goals are arm position and visibility. You want to adjust the wheel so that your arms are slightly bent when your hands are at 9 and 3. And you need a completely clear, unobstructed view of your dashboard.
So no locked arms, no hidden speedometer.
Never drive with your arms locked straight, and never let the wheel block your view of your instruments.
We talked about safety features. What about the steering wheel lock, the anti-theft function?
That only engages when the car is off and the key is removed. The guides are very clear on this. Your steering wheel should never lock while the car is moving. If that ever happens, and it's an extremely rare, severe malfunction, You need to pull over immediately and get it inspected. That's a catastrophic failure if it happens at speed.
Finally, steering wheel covers and those little knobs you sometimes see. Safe or unsafe?
Covers are generally okay if they fit snugly, are non-slip, and don't get in the way of the airbag. The knobs, though, sometimes called spinner knobs or suicide knobs, they're viewed much more cautiously.
Why is that?
Because of the high risk of severe injury in a crash, that knob can cause a lot of damage, and it can interfere with making rapid steering corrections. Safety experts really discourage their use.
We definitely went deep. To summarize our key takeaways for you, always keep your hands at 9.3 or 8.4. Protect yourself from that airbag. When you're in a slide, steer into the direction of the slide, and critically, avoid that overcorrection by immediately straightening out the moment the car recovers. And you now know the vital difference between a cheap fix, like low fluid, and an urgent risk, like loose tie rods.
And if you connect this all to the bigger picture, the key insight is just recognizing that these components you never even see, that caster angle pulling your wheels straight or the exact torque on a wheel bearing, that's what gives you the confidence to drive safely. This knowledge of the unseen mechanics, that's the real shortcut to becoming a truly well-informed driver. Use this to pay closer, more critical attention to your car's feedback. It's really the best defense you have on the road.
Please like, subscribe, and get notified.